Hey, good afternoon, everyone. I'd like to thank you all for joining us today for our webinar series. Today's featured topic is connectors, types, and polishes. My name is Jessica Petrohoy, and I'm the marketing manager at fiberoptic.com. Fiberoptic.com is a leading provider of fiber optic products, training, and rental equipment. We're pleased to present this topic to you today. With us today to talk about fiber optic connectors is Adam Goth. Adam is a technician for AdTel integration and also a member of fiberoptic.com's sales support team. Adam will be discussing the different types of connectors and polishes, along with considerations when choosing your connectors. When Adam is finished, we will take questions from the GoToWebinar question box at the bottom of your screen for a question and answer session. Remember, our webinars are posted online at fiberoptic.com/webinar. So you can view this in the future for online streaming. All right, thank you again for joining us today, and at this time, I turn the presentation over to Adam.
Thank you, Jess. Really appreciate that introduction, and I want to thank all of our attendees and our listeners for joining us on our webinar Wednesday that we have 3 p.m. Eastern Standard Time. We have this every month, at least once a month. Sometimes we're going to have more than one, but we're going to stick to at least one a month. Want to give a little introduction about myself. This is my second year in a row going over connectors, types, and polishes. I will be hosting, your presenter, your moderator, your guide through this short journey during today's webinar. I'm going to be the guy taking you through it, giving you the play-by-play. I took over for Terry Powers, who happens to be one of our senior professors at the Fiber School, been with us for close to 15 years and has over 25 years experience working in the field and with us. And wanted to just give a shout out to him and a thank you to him for all of the time and education. And I'll keep carrying the torch, Terry. So thanks. And back to a brief journey about myself in this fiber world and the Fiber School. The Fiber School originated back in 1995. That's right, and has been educating students ever since. I myself have not worked in the fiber field quite that long. However, I've worked directly in the field, hands-on, in the sales, in education, and even in project management. Everything from splicing, testing, site walks, emergency response, new builds, and old refurbishes. I've kind of been there, I've done it, and now I'm going to be going over connectors, types, and polishes. And this is really an excellent course to start out with someone who's never really been in the fiber world. You know, they're a little newer, not so long in the tooth, a novice, if you will, a beginner, or even somebody that's been working in the field for a while and just wants to sharpen their skills, wants to kind of educate themselves and get the correct lingo and Django down as far as fiber skills and connectors, types, and polishes. So what we're going to do is going to jump right into it and start getting into our agenda here, which we're going to go over our overview, connector types, connector polishes. And like I said before, this really is a wonderful webinar for the beginner to novice, person starting out working with fiber. We're going to go over the essential elements for most connectors, those connector types and connector polishes. All questions, I just wanted to say I will answer at the end. If you can just please save them for the end, jot them down, script them down, and we'll address them at the end. There's usually quite a few, so I'm going to try and keep this to approximately 45 minutes. We started a little late today, and I apologize about that, but we will go ahead and then have plenty of time for all of those questions at the end. and get you taken care of and squared away. So we're going to dive into the connector overview. And what we're going to start talking about is the essential elements in most connectors. They're the connector's anatomy. The end pressure control device on the connector is obviously to control the pressure to not damage the fiber. The alignment sleeve simply is right here, as you can see. This allows the fiber to match up or pair up completely. And when I say completely, there's a perfect match, and they're mated so that you can have the transition of light, information, and technology. So the alignment sleeve is very important with the connector. There's anti-rotation devices which keep the fiber from moving, bending, getting out of the connection. The strain relief system is obviously to alleviate any pressure on the fiber and continue to allow that fiber to process data and get the information that's needed to the people that are trying to obtain it. The adapter receptacle is going over all the different types of ferrules that we're going to be looking at. And as you can see, this is a ceramic ferrule right here, but the ferrules can be made of steel, polycarbonate, or plastic. Ceramic, you usually end up finding you have a better dB loss with ceramic, in my personal opinion, although I found that plastic is also very good and can help out very, very well as far as the performance of your fiber. So this is a basic breakdown of a connector overview. And we're going to dive into this a little deeper, and there's going to be some repetition, but what you're going to get out of this webinar today is you're really going to get a good understanding. You're going to get the vernacular, the verbiage of what you need to say when you're on site. It's important to know how to splice, how to test, but it's really important to also be able to vocalize that and come across as a professional instead of just saying, well, give me the green connector. Give me the blue connector. It's give me the Sam Charlie, or sometimes you're going to be dealing with people that only use the SC, LC, TC, Whiskey Tango, the short lingo. And you need to, if you're dealing with a knock or if you're in a situation, you need to know what somebody's talking about and how they're coming across, so you can truly understand what you're up against and what you're looking at. And you'll hear that repeated over and over again when I'm reviewing each different type of connector and how they work and the ins and the outs of the different types of connectors. So something that is always considered when going over connectors or when you pick a connector for a particular job, these are the 6 areas that are always come into consideration. If you notice, the very first consideration is cost. Cost is the first consideration, and it's the number one and most important. And the reason why I say that is because each connector can cost an extremely large amount of money. And when you're putting 250 connectors in one area at a mall, and that is one RU unit, or that's just the FAP alone. If you have 19 RU units throughout a mall and there's 250 connectors per unit, you can do the simple math and can see how connector costs is something that's extremely important. Installation cost is discussing or taking into consideration, the actual physical placement of the connectors at a facility, but it's also the cost of the time for the people that are putting it in. So that's also considered or taken into consideration with the costs and the connector costs. Ease of installation. It's something that is extremely important depending on where you're located. If you're doing it at a tower, if you're outdoors, if you're indoors, ease of installation is something that's always needed to be considered, especially if you're up in Alaska compared to if you're down in Texas. Ease of installation, that's going to be something that's very much taken into consideration for those particular elements. Your loss budget or your connector style, this is extremely important and once again ties back to cost. Your loss budget or your connector style, certain jobs, certain cell phone carriers, T-Mobile, Sprint, AT&T, Verizon, they have a loss budget and you have to stick with that. So the particular connector styles may prohibit you from using those connectors because they don't fall into the loss budget where you're supposed to. And that is also broken down to the ferro material that we'll go into in more detail, whether it's ceramic, steel, or plastic polycarbonate, polycarb. There's two types of connectors that we're going to be discussing today. There are others, but the two that we're going to be going into is the standard, which is 2.5 millimeter, and the SFF. And this is one of, nobody says small form factor. That's what SFF stands for. What it is, it's that's just what people say when they're in the field. SFF, SFF, SFF. They don't say small form factor. So just one of the things when you're out in the field, being able to talk the talk, not only walk the walk, so you just are that much marketable when you're out there in the field dealing with people. Or whether if you're doing a project management and you're on the phone with somebody, being able to speak knowledgeably about the field is something important when dealing with connectors and your connector considerations. So repeatability. Getting the same loss each connect and disconnect is so important, and that once again ties to cost. If you're going to pay less for a connector, well, your repeatability is most likely going to go down because the connectors are not that much of a quality, where if you're paying more money for a connector that has high quality and provides you with exceptional dB loss and allows you to repeat that, well, you're going to be paying money for that also. And then it breaks down also into time. So there's the anaerobic style, the 3M hot melt, and then the quick termination. And this just breaks down the ways, 3 different ways that you can go ahead and terminate a connector. So cost consideration, there's 6 of them to go over. First is cost. Second is ease of installation. Third is loss budget. Fourth is size. Fifth is repeatability. And the 6th is time. Once again, they all tie together. In all honesty, it's going to come down to costs. You can take all 6 of these, and if 5 out of 6, size, repeatability, time, loss budget, ease of installation, if you have a budget, and when I say a budget, I mean a cost budget, you have to fit it in there, then you're going to go with the connectors that fit into that loss budget. So now we're actually going to break down connector types. Like I said before, there is standard connectors, small form factor connectors, which is SFF, because nobody actually says it the whole way out. The industry is just constantly changing. It really is. It's a 15-year industry, 20-year industry, but it's truly in its infancy. You need to stay familiar with the changes in the field. It's not only important to know what you're working with or working on, but it's important to be more knowledgeable about the products and the parts. The reason why I stress this is I don't want to say that calling a SAM Charlie or an SC connector, an LC connector, a simple mistake like that. I'm not saying it's going to cost you a job, but it is possible that it could cost you future jobs or cost you questionable credibility as to your employers wondering, do you really know what you're talking about? So like I said before, it doesn't mean that you would lose your job, but it's possible they might not bring you back. They want to make sure that people that are being hired, not only can do the job well, but can also vocalize that and help them out when they need some help. Because some of the people that you may be working with while dealing with connectors and connector types, they might not know the industry themselves. So the better educated you are, the better off you are. And at any time, you're more than happy to, or more than welcome to reach out to me at adam.goth@fiberoptic.com. And I'm happy to help out with any questions if I don't have time to answer them all at the end of this webinar. But once again, that's adam.goth, that's Goth, @fiberoptic.com. So people that you work with, they really do quickly pick up if they feel that you are not 100% on, the areas that we're working on in connectors and fiber. People like to call people in the field like that greenhorns, and we definitely, have a lot of that. So without further ado, we're going to dive into the connectors here, connector types, break down the different types of standard connectors versus the SFF connectors. Now I'm going to start throwing the lingo at you, and here's where you're going to start seeing what I mean. Standard connectors, ST, FC, and SC. SFF connectors, MU, MT/RJ, and nobody says it that way, LC, MPO. All right, so for standard connectors, which is what we are most likely going to see in the United States and in the fields that are offered right now. Doesn't mean to say you're not going to see small form factor connectors. You certainly are going to see the LC. That's just the smaller little brother or sister of the old SC. But we'll start off with the Sam Tom. That's the nickname out in the field, or the ST connector. All standard connectors, you're looking at 2.5 millimeter. The Sam Tom, which is a straight tip, that's what it stands for, was developed by AT&T predominantly, I don't know, about the late 1980s, really early 90s. And the ferrule, however it's keyed, is always 2.5 millimeter. It's most commonly used in network applications. The FC is a fiber optic connector with a threaded body, most commonly threaded. Single mode optimal fiber, polarization maintaining optical fiber, designed for use in really high vibration areas, high vibration environments. The SC, which is extremely popular, the Sam Charlie, is a subscriber connector. Nobody really says subscriber connector, so that's why it's the old SC, the Sam Charlie. Uses a push-pull latching mechanism. That's what makes it popular. It's a fiber optic connector that can easily be placed in and taken out because of the push-pull latching mechanism. Now, in the small form factor connectors, the MU, which is a miniature unit, is what it stands for. All SFF are 1.25 millimeter. The miniature unit, that's really common in Japan, overseas, Japan, China. The MT/RJ stands for Mechanical Transfer Registered Jack, supports full duplex. The LC, which was popularized by Lucent and brought into this world by Lucent Technologies, is, like I said, just the little brother or sister of the SC. Very, very similar, but the LC is 1.25. Looks similar, just half the size. The MPO is the multi-fiber push-on. You don't see this currently. I mean, it is out there, but I really foresee it maybe more in the future, but it just hasn't really taken off yet. Common connectors. It's funny, it's almost like I'm browbeating you guys with this, but this is how you kind of got to get it into your head, because it can easily get mixed up. ST, FC, SC, Sam, Tom, Frank, Charlie, Sam, Charlie. Small differences, but it's extremely big. The Sam, Tom, or the ST does multi-mode and single mode. Local area networks is the application. You can see in the image here, now this is a drawing. I'm going to show you another one of an actual, the connector itself, but this is primarily how it's shown with the images. Very, very common. The Sam Tom's out there, it's very, very common. The Frank Charlie is only single mode. Common in telecom. Maybe you've seen some of these with your TVs. Non-optical disconnect. The Sam Charlie, another reason Sam Tom is very popular, because it's been out there for a while and it's one of the least expensive. The SC, most multi-mode and single mode, the Sam Charlie, does both telecom and local area networks. Here's the push-pull mechanism. You see how it's kind of squared off here? Protects the ceramic, steel, or polycarb, plastic, ferrule, but it gives you a good connect and a good disconnect every time. Snap in, snap out. So the ST connector, it was first developed by AT&T, 2.5 millimeter ferrule, and that's for all standard connectors. Round with locking tabs. So you see how around the connector here, right where the ferrule here, which is completely naked, not a whole heck of a lot of protection there, but it has a lock-in. So you kind of turn and it locks right in. You're not going to see these come out. It was the very first one adopted by the standard. The IEEE 802.3 is just the Institute of Electrical and Electronic Engineers. If you wanted to know, it was formed back in 1963 in New Jersey. Over 400,000 members now worldwide. Maybe something you want to join in the future, like makes you just that much more marketable. But this is who regulated the ST and the standard. It's still the most common in multi-mode applications. And one of the biggest reasons is, going back to the pages before, is cost. This is the least popular in my opinion, but cost-wise, it's just, it's still used. Declining in popularity, but in high vibration environments where these can become loosened or disconnected, these will be locked in and you won't have that as an issue. So between cost and the reliability, still the ST is still around and still popular. The FC connector is historically used in single mode applications. There are other applications where it can be used, but for the most part, single mode is how you're going to see the FC. It screws in. That's the difference between, the other standards. This is a screw-in, where the other locked, this is a screw. And it's a firm fit. But once again, it's being replaced by SC and LC. So used again in the telco market, always the 2.5 millimeter ferrule, but it has a great pull-out strength. So it really is. It's amazing. Some of the best you'd see out there in the market. The SC connector, which is really dominating and will take over for the 2.5 standard connector field, is the subscriber connector. You've got the snap in, snap out, where you see there's more protection here, better connection. You're going to see this primarily in blue beige or red. Beige, that's more of a gray to me, but you'll see this mostly in blue. Low loss, has awesome pull-out strength. The SFF connectors, any application involving large number of fiber is a high candidate for high density connectors. You got to go smaller. There's only a certain amount of room. You know, in cities where there is just no more room to put these infrastructures, well, you have to save on size. So you go from 2.5 millimeter to 1.25 millimeter. Amazing that in maybe 5-10 years we'll go from 2.5 or 1.25 to even less than that. So high density connectors, data centers, premise cabling, telecommunication rooms, FTTX infrastructures, all places where you really got to cram a large amount of fiber into a very small place. So it's amazing you go from 2.5 millimeter to 1.25. Small form factor connectors being half size, they always help to provide that answer, help to provide a solution for that question. I don't know if it's the answer because they'll end up removing those and going even that much smaller than in the next 5 to 10 years. But bigger, faster, quicker in America? Well, in this case, less is more. Smaller. Size. You want to go smaller. That's the best way to go in this situation because you can get more in there. All right, this actually breaks down the SFF connectors. You know, with more and more fiber going into our communication rooms and no additional space available, small form factor connector types are increasing in popularity. Small form factor refers to any of the several physical compact connector types that have been developed to deal with the increasing density in communication spaces. We just need to get more into smaller places. People need their communication. People need their information. People need their sports, news, weather, whatever it happens to be. We have to get it there faster, but the only way we can do it is to make things smaller. There's just not enough room. You know, so now we're going to something that's typically about half the size of the conventional standard connectors, and most have that 1.25 millimeter ferrule. The SFF connectors, we're going to go over these. The VF-45 Volition, that connector was designed by 3M and consists of two-part plug and socket configuration. The connector uses two 8-degree cleaved bare fibers, spaced 4.5 millimeters apart, and holds the fiber in V grooves rather than the ferrule. The VF-45 is only used as a duplex style connector. Here's the one you're going to see as far as the SFF the most, the LC. This is the game changer right here, but I'm going to leapfrog all over that real quick and go into the MTRJ, which was designed by AMP and is the smallest of the small form connectors. The footprint of this style connector is half of the SC and uses a plastic ferrule in a duplex configuration. The fibers are spaced 0.75 millimeters apart. Don't see it as often overseas and international. The MU, as I said before, Japan and China, the Pacific Rim, very popular over there. The MU was designed by Tyco and is available in either simplex or duplex. The MU uses zirconium ferrule and was designed based on the SE connector. So bigger, not always better. Smaller is the future. So getting back to the LC, the reason why I leapfrogged over the old LC here is because I wanted to give the LC the proper attention that it really deserves. It's the one that's the front runner as far as going over the SFF connectors. The LC connector, which was designed by Lucent Technologies and is used in simplex and duplex applications, 1.25 millimeter ceramic ferrule, and they really feel that that's the big difference, with the fiber spacing of 6.25 millimeter, has the lowest insertion loss. It's 0.1 dB average of any of the small connectors. So it's one of the smallest, it's one of the most reliable, and it's a fan favorite that Lucent, who is no longer with us unfortunately, but still has that name out there, and that's what the old LC connector is one of the front runners. Small form MU, single mode multi-mode MU connectors are small form factor connectors, approximately half the size of the old SC, just as I said before. Got to repeat it, got to make sure that you understand it thoroughly. This gives you a little bit better of a picture here. This black sleeve right here, that's the push-pull design that it's discussing. It's free floating, so it allows you to hold the ferrule in place with precision, and it has a spring, so it's got the push-pull design. This is the MTRJ, and once again, single mode, multi-mode, something that's very nice, used to fiber applications and well suited for the high density applications, very, very well suited. Just not super popular, and one of the reasons is cost. What gives the precision with this particular SFF is the metal guided pins. With those housing dimensions, it ensures every single time when you mate that fiber, you're getting a fiber alignment, almost a perfect fiber alignment, and that's because of the metal pins, and you can see like the two little holes right here. It's reliable, and it's simply, very, very simple to terminate. One issue with it is, it's not inexpensive. It's a little more money with the old MTRJ. Maybe that's why it hasn't really caught on over here yet. Here's the LC. You can see how this guy, and sometimes they're paired or they're single, but you can do single and multi-mode. Still manufactured by OSF, Vitel, which, formerly is Lucent Technologies. The LC, SFF, is the ideal in high density applications. You just can get so many of these little guys in such a tight, small, confined area, and they work really well. And push and pull. You can see this, right here, this little plastic tip, you press down on that, and that's what gives the lock in, lock out. So it's almost like a pin. If you don't press down on this and apply pressure, it won't release. So it's nice because it locks right in there for you. The LC connector has a ferrule measuring 1.25. Once again, that's all SFF, and either a PC or APC interface, and provides optimum insertion and return loss. The LC connector is used on small diameter mini cordage 1.6 mm and 2.0 mm, as well as 3.0 mm cable. The LC connector family is Telcordia, ANSI, EIA, TIA, and EIC compliant. Everybody loves the LC connector. It's the fan favorite. It's good on cost, it's good on performance, it's good on repeatability, and that's one of the reasons why it's more predominantly used in the United States. What is an MPO connector? The MPO is the acronym for multi-fiber push-on. The EIC and the EIA, TIA, this breaks down both internationally and for the US standard. The MPO is often used in FTT applications as well as pre-connectorized drop cable and as well as gaining popularity as an indoor premise backbone. More commonly internationally, and it has a higher cost here in domestic. So now we're going to get into some non-polished or no polish connectors. This actually shows one broken down here, separated from each of its spots. These mechanical connectors contain an integral fiber stub and an index matching gel. The stub is bonded to the ferrule and factory polished. You can polish out in the field, but these are polished in a factory, so there's a little less opportunity for human error. There's some great people can really polish the heck out of some fiber, but I find that factory polished connectors just perform that much better, more reliable. The fiber to be terminated is stripped, cleaved, and cleaned. Then it's inserted into the back of the connector and mechanically secured. While significantly more expensive epoxy connectors, the time savings this makes a cost-effective alternative to scribing and polishing in the field. One thing I also want to add is there are a couple things. I feel it's that much more reliable. In my personal opinion, if you have the option, there would be no option. You would not be scribing or polishing in the field. You would simply use a mechanical connector just because it's more reliable, less chance for high loss, and even if there's a higher cost associated with it, the man hours for polishing and scribing is that much more added to the project management side. So, I don't feel there's really an option there, but there is an option. So that's something that's nice. That's just my opinion. So instead of scribing and polishing in the field, this is a nice alternative and can allow you to get the job done. So now we're going to break down into connector polishes, really give you an idea of the differences between the green and the blue, colored connectors and the beige and the red and why they're in that respect. Once again, if you have any questions, we can save those for the end, and I do see a few and I can address those. So we're going to get right into the actual what the connectors kind of look like. Now, fiber is the length and thickness of human hair at times. So these drawings give you an opportunity to really see what the top of the connector looks like a little bit better without putting it under a magnifying glass. So there's four main types. There's the flat, the PC, the UPC, and the APC. The UPC and APC are two of the more popular, and that's because of the back reflection. They perform much better than the flat and the PC. Once the optical fiber is terminated with a particular connector, the connector end face geometry, the connector polish, will determine the amount of return and loss back reflection. So as they have it on kind of a sliding scale here, from flat being the worst performing to the APC being the best performing. Not saying that the flat is not used and is it's still used today. It's just as far as the back reflection does not perform as well as APC on the back reflection side on the dB loss. So minimizing the back reflection can be really, really critical for the proper performance of high-speed laser-based fiber optic systems. The speed in which you get your information, your TV, whatever it happens to be, your security, your defibrillator, whatever it happens to be. So now the connector polishes, we're going to break down in a little more detail. The flat, once again, kind of gives you a breakdown here of the image. Most mostly found on metal ferrules, not as popular as the PC ferrules, and there is the significant back reflection on single mode. That's the SM. SM single mode every time, multi-mode every time. The PC, physical contact, domed ferrule, see how it is slightly domed, is usually ceramic, where the flat was usually metal, neg 30 dB back reflection. The XPC, that's just a little bit of a higher grade of the PC, is a super PC, or physical contact radius dome. So now the dome is slightly higher, as you can see, elongated even that much more for a better back reflection. Once again, usually ceramic ferrule. There has been some going plastic lately, but a neg dB of 40. The next step up is the UPC, the Ultra PC. High radius dome, as you can see again. Ceramic ferrule, big difference, neg 55 dB. So now you can see why the UPC and the APC are more popular. Less issues. The APC, angled PC, angled physical contact. 8-degree angled PC, ceramic ferrule, it's a neg 70 dB back reflection. Big fan favorite. Why so many connectors? So many different applications, so many different requirements, whether it's military, government, is it AT&T, is it RCN? Everybody has their own rules and regulations, and these are all regulated the same way, but every project manager just has a way that they like to do things. So that's why different companies offer different plans. Cost is always a factor. So now you can see why I keep repeating myself slightly here. Flat, PC, XPC, UPC, APC. Know your jargon. Know what you're talking about. Know your lingo. So that way you know what to say when you're in the field. And you sound like you know what you're doing. So it really makes you stand out. Just makes you that much more marketable, and you avoid problems in the future. Now we're going to get into reflection issues, and this is kind of showing you here what we're looking at as far as the angled physical contact. We always just say APC, connector cut to an 8-degree angle which directs the light away from the source. So you can see how the angles are different here. So the ORL, the optical return loss testing, tests back reflection, which is detrimental to high-speed laser communication. Special polished connectors are XPC, Super PC, UPC, Ultra PC, APC, Angled PC. PC stands for physical contact. So you can see the differences in the physical concept. These special finishes change the geometry of the ferrule face and are used to reduce the amount of light reflected back on the fiber. APC, one of the best dB losses, neg 70 dB loss. They're green. Best performance. Anything with the best performance, best football player, best baseball, best swimmer, best racer, they're making the most money. Green body and sleeve. Least back reflection, used in Cat 5, Cat 6, FTTX, and testing applications. Properly mated APC connectors are they're virtually perfect, really, and invisible to an OTDR. What's an OTDR? We'll get to that in future webinars on a webinar Wednesday, but that's what tests your connectors. Now, I promised that I would save sidebar for some time for questions here. We are approximately 45 minutes in. I do see a few questions here. I appreciate the nice high attendance we've had today. 39 people that sat through me squawking for a good 45 minutes about connectors and polishes. One of the questions I see here from the round table is, where can I find a schedule? And are we having future webinars? Like I said earlier, we are going to have it always Webinar Wednesday. It's going to be 3 o'clock. We are doing at least one class a month, and it will be posted on the webpage, fiberoptic.com, and you can go ahead and just peruse on there and see the existing webinars that are already there, and also see the ones that are upcoming in the future. Here's a good question. What is the red connector in the webinar? Well, what is that? It's the red connector is primarily used for military applications. It signifies usually critical circuits. So that's a very good question. I know that they usually are blue and beige or gray, but yeah, that's what that one happens to be. Really do appreciate everybody coming out and sitting down for the webinar, and look forward to seeing some of you guys in the upcoming future. If you have any questions or concerns, like I said, feel free to email me at adam.goth@fiberoptic.com. I do see some other questions here. As an independent contractor, would you recommend purchasing the different connectors in bulk for different jobs on our own? That's a good question. We at fiberoptic.com not only do education, what we're going over right now, we also do products, and we are happy to get you a quote on that. So just go ahead and email me. Excellent question. Happy to get you a quote. We deal with all companies out there, and we also do services here. So if you ever find yourself working in the field and in a pinch, we can do splicing, emergency response, OTDR testing, new build, refurbishment, old build. You can also obtain a copy of the presentation. Another question I just received. And best way to do that is to just email me at adam.goth@fiberoptic.com, or you can go right to fiberoptic.com/webinar, and you can go ahead and obtain a copy of the presentation that way. Thank you very much for the thank yous, and once again, attention. Hope this webinar was useful and valuable. I always appreciate everybody's time on the Happy Webinar Wednesday. Look forward to talking with you guys again in the future. Hope you all make it a great day.